Hello, I'm Terry Ord from the Evolution and Ecology Research Centre at the University of New South Wales in Sydney. So we can get a lot of really useful information by just observing animals doing what they're doing in a wild population. But often we would really like to be able to individually identify those different individuals within the population so that we can then go and do repeated observations on those same individuals at different time points. Now, our traditional methods of doing this involve having to catch the animals, which is less than ideal because, that's an invasive approach, but also putting some sort of unique tag on those animals. I've got a few examples up on the screen here. Now, these tags in themselves can be a potential issue as well. I just want to focus on the eastern grey kangaroo example that's in the bottom right-hand corner here. Putting collars on these animals can be problematic. These animals will start scratching underneath those collars, potentially get their forearms caught in those collars. And if it's a wild population, having a forearm caught is not going to end well for those individuals. So this is a very invasive approach of individually IDing animals. So in our case, and the reason why I'm talking about this is that we've been doing a long-term monitoring program of a wild population of eastern grey kangaroos in the New South Wales Central Tablelands. It involves using video and also an annual photographic survey. And we've been doing this for the last decade. So we sit in a hide, we take multiple photographs of every single individual within the population over several days. We come back from the field with a library of images that's in the order of about 1,000 to 1,200. Up to recently, we've been manually identifying those kangaroos with the assistance of a program called I3S Contour, which was originally developed for tracing the individual markings or the pattern of marine mammal tails. We've been using it to manually trace the inner ear of our kangaroos, which turns out to be a really useful fingerprint, if you will, of individual identity. So it's a huge amount of work, but after that, we are able to determine who is who in the population from this photographic survey. We do this every single year, and we can follow the individual fates of individual animals. Why would you bother doing that? We'll just zoom in on that photograph. That plot that I just showed you before was about 196 individuals that we've been tracking the fate of in this population over the last decade. This is a single female that we saw in 2015, and we've seen her in every year since. We spotted her as a subadult, and then she grew up the following year and started to reproduce. So the information that we can get from this is straightforward. So we know how old this individual is because we know when we started observing her, and we also know the years that she's been reproducing. So we know that this individual has reproduced in every single year as an adult, except for 1 year, and that was 2017. The other information we can get from this is that we have photographs of individuals in proximity to each other, and we can use this information, as long as we know who is who, to create these social networks for the population from 1 year to the next. And one of the discoveries we've made purely from this annual survey was that females tend to form long-term bonds with other females that go for many years. So they are essentially creating these kind of long-term friendships, if you will, which is a really exciting discovery. We can also get really basic information on growth trajectories. So this is a male that we spotted as a subadult in 2016. 2 years later, he was a full-grown, very bulky male in 2018. We can use things like proportional height to get estimates of growth trajectories as a consequence of knowing who is who and doing this proportional height sort of approach. Now, this way that we've been using individually identifying our kangaroos is hugely laborious, and it's assistance with this other program, but it's not very effective. AIs have been progressively applied to wildlife research. I've got a few examples up here that have been developed for individual recognition of birds or the faces of primates. There are three major limitations with these current systems. All of them rely on massive data sets. So the smallest one in this instance was 25,000 individuals, images of individuals that you already know who they are, to just train the AI to be able to recognize those individuals. These accuracy rates, these like 92, 94%, is dependent on recognizing the same individual that the AI has been trained on. So what we call a closed set problem. That's not very realistic for a wild population because new individuals are always coming into the population through dispersal or through birth. So that's a challenge. And one of the biggest limitations is that you have to be pretty good at your programming skills. You have to know either MATLAB or Python and need to know that pretty expert level to be able to mold these existing AIs for your own means. Wasn't going to be useful for us. UNSW was very generous in providing us funding, and I worked with some collaborators in computer science, gave them the brief of the end product has to be something that a non-expert can use. It can be used on uncurated images, so images that are taken out in the field under different lighting conditions and different postures. And also, it's going to be a limited data set. So at best, maybe several hundred, 1,000 images to train these things up. Has to be tailored recognition. So for others to be able to use it and for me to be able to use it when new individuals are coming in, I need to be able to deal with this open set problem. So they came up with a different solution to what most people are doing at the moment. They decided that the best approach would be to develop an interface that marries together existing open source off-the-shelf systems to provide a kind of assistance tool, a start point that people can start using to train a neural network for the individual recognition of their animals, and that they can then progressively refine that network without programming skill. So there's progressive training or progressive refinement. There is a two-part pipeline in the system that they've developed. I won't go into the details other than to say, first, there needs to be a system that knows what to do with these images. So we've got the system to focus on extracting face headshots because that's where most of the individual recognition features are for these animals. It's reasonably accurate at about 97% precision. The meat and potatoes, of course, is this classification, so this recognition problem. So my collaborators were tinkering around with a bunch of systems that were trained on human face recognition. They were more interested in just refining this pipeline rather than expecting those systems to work. They fed it a bunch of individuals, about 96 individuals, 5 photographs each, to train this kind of human face recognition neural networks. Not surprisingly, quite a few of them just fell flat, couldn't do it because they're trained on human faces, right? Not kangaroos. But there were a couple, one in particular, that did surprisingly well. Ghost FaceNet, again, based on human face recognition, train it with a limited set of faces of kangaroos, was then able to accurately determine 66% of the time the correct assignment of those individuals. The thing is the way the system is set up, it shuffles those images into corresponding folders, and it's much easier to just go in each of those folders, look at those images in there, and shuffle them around for the ones that are actually correct. Doing that and getting some fresh data on these same individuals the following year, fed that back into the system that they've created, we got the system up to 98% accuracy on that second training, which was fantastic. It was really surprising. We've packaged this whole system together in what we call WildAIID. It brings together a host of image detection, image extraction, the faces, the recognition, which is the GhostNet, but importantly, a drop-down menu that will allow you to then train the AI repeatedly as you get new information. So the idea is that to circumvent this kind of limited data set and open set problem, here's the assistance tool. You do need to have a starting base of images that you do know who the individuals are. Run it into the system, train it. You'll get in the order of about 50 to 66% accuracy. But because it's all set up, it's way easy to go in there and verify and then retrain. So the idea is that you go out and survey your population, you feed those images into WildAID. That takes about 25 minutes to then determine individual IDs. You then go in there and verify it, which is pretty quick because it's, afternoon's worth of work basically. And then you reshuffle those images, create new folders for those new individuals, retrain the AI overnight. It's less than 6 hours. The following morning, your AI is ready to go. Collect more information, survey that population again, and you'll be able to get your AI in individual recognition up to reasonably good accuracy very quickly doing this process. The alternative way is to do it by hand, of course. As an example, is to compare those timeframes for 1,000 images and for an expert who's knowledgeable of the kangaroos in this particular population, has been studying these animals for years. Assisted with this contour program, it took over 28 hours to assign individual identity to 1,000 images. That's a long time compared to what it's like with the WildAIID. Not 100% accurate, but it's significantly quicker to go in there and correct it and then retrain. You'll be able to then get information on social networks based on who's associating with who, potentially growth rates, but you'll be able to track the fate of individuals from one time point to the other, who's surviving, who's reproducing. Very easy through a non-invasive means, as long as you are able to individually identify the animals. WildAIID will do that for you. It's designed on kangaroos, so it will work on kangaroos. We actually suspect that it will work on anything that has forward-facing eyes and where the face has uniquely identifying characteristics. So if that seems like it fits to your system, give it a go. It's free. It's available for Windows only at the moment. We're still developing it. So it's a work in progress, but it is functional right now. Check it out. And just like to acknowledge my co-authors, Tarek, Hamza, and Eric, my wonderful computer science colleagues. Just spot the field biologist here. So they were fantastic, very patient, explaining everything to me and working with the devil in the detail with this particular problem. UNSW has been really generous through the 3Rs grant scheme that funded this entire work. And thank you for listening.